everyone, and welcome to Creating Equations Part 2. We're going to go over a little bit more of how we can create equations based on situations, but this is going to be a little bit different from the last video. We're not going to be focusing on the distributive property. Instead, you'll see in a moment. Make sure that you get your book before this. Pause the video if you have yet to, but go ahead and get your book. All right, let's get started. So we're going to be talking about creating equations that look a little bit more like this, where we have a variable on both sides. And typically when you have a variable on both sides, it's kind of hard to solve it until you only have one variable. So an example like this, I would get rid of this minus x. It's smaller than 5x. So let's just add x to both sides, right? And that would result in getting rid of this x, because your goal is so there can only be one x, or one variable in general. So I want you to keep that in mind. There can be only one. Until you have only a single x on a side, you won't be able to solve that equation. But let's go ahead and try to create an equation that looks like this before we actually try to solve it. So let's take a look at this example for today. Go to page 59, and we'll go over example B, which should be the only example on that page. It says one moving company charges $800 plus $16 per hour, and another moving company charges $720 plus $21 per hour. At what number of hours will the charge by both companies be the same? And then what is the charge? So I'm noticing that we're asked at what number of hours will the charge by both companies be the same? That's our first question. And then of course we're asked, what is the charge? So when we create a way to represent this, let t represent the number of hours that the move takes. Because our first question is what number of hours, right? Now, keep in mind that t is typically used for any time interval, not just for hours, minutes, seconds. But let's just have t represent our hours for this case. So I'm going to take a look at the first situation. One moving company charges $800 plus 16 per hour. So I could say the moving charge, just A, start with A, whatever the moving charge is, plus $16 per hour. And then for the second part, we could say, just to simplify this, moving charge, just have a moving charge B, whatever that is, the cost, plus $21 per hour. So we have this equation right here. The left side represents the first situation. The right side represents the second situation. And our goal is to see when are they going to be equal to each other. Because how many hours is it going to take for them to be the equal cost? So for here, we know we have 800 plus $16 per hour. And the other one is 720 plus $21 per hour. And if you're wondering, trying to make this equal, why did someone even ask this question? Well, think about it this way. If you're trying to choose which company, you obviously, the second company starts off cheapest, right? But you want to figure out at what point does it no longer become worth it because it charges more per hour than the first one. Anyways, let's go ahead and solve this equation. So remember, there can be only one, and yet we have a t on the left side and a t on the right side. There can be only one. So let's just get rid of one of them. Why don't we go ahead and get rid of the 16t by subtracting 16t on both sides? What happens is, right, this crosses off and goes away, leaving us with 800. And then on the right side, 21t minus 16t, well, 21 minus 16 is 5t. Now that we're in this situation here, let's try to get t by itself. Let's go ahead and subtract 720 to get rid of it. If I subtract 720 on both sides, the 720 will cross off on the right side and leave us with just 5t. Meanwhile, on the left side, 800 minus 720 is 80. And now we're almost done. Let's try to get rid of this 5. 5t. What's the opposite of 5t? Isn't that 5 times t? The opposite of multiplication is division. So both sides, I'm going to divide by 5. That cancels it out on the right side. Slice right there. And then 80 divided by 5 is 16. So our final answer is t equals 16, right? We're done? T equals 16. We're good to go? Well, look what... We could stop here, but look what what's actually asking us, right? It says, at what number of hours will the charge be both companies charged by both companies be the same, but it's also asking us what is the charge at this 16 hours. So how can we figure out how much it's going to cost in 16 hours? Well, couldn't we just take our answer and put it into one of the sides? Or we just put it into both sides, because not only will it tell us the answer, but if they are equal to each other, we know we're correct. So let's simplify that. 16 times 16, 21 times 16. Guys, don't do that in your head. Put that in your calculator. It gives us 256 and 336. And then we add these together, and we get $1,056. That is expensive. You might want to try to ask some friends to help you move out instead of paying these companies. That's really pricey. Regardless, notice how they're both the same, and we know the cost will be 1,056. So our final answer is, after 16 hours, the moving charges for both companies will be $1,056. And that's it for this example. I do want to emphasize, guys, that you must, absolutely must, check your work. Otherwise, you're never going to know if you're right or wrong. This is Mr. Porter, signing off.